All right. So can you show me the code?
This meeting is being recorded.
Yeah. The code back. Yeah. The first wall. No. Just go to the functions. The wall function creates the wall. The other one, other window, which is behind this. This is the
This one?
shell now. Yes, that one. The wall function is creating. Okay, that is the window function is creating that window, right? So okay. And the house function is creating the house. The door function is creating. So what if you have changed the sizes and all? So can you execute that again one more time by giving these parameter values, means RL and WL. So that is RL is roof length, wall length. So we have like studied like this we have discussed last day, right? So can you just put some value there and see what will happen? So no, don't change the values manually. Don't change the manual value. Just run it again. Just run it again. Run the code again, please. Okay, so can you put, right, go to the shell now. Go to the shell, right? You can close it even. Please go to the shell. Shell is the other window.
Oh, this one, yes.
Okay, then put house. Start type in house function. Open the bracket. Now put your values. Put your values. You can put maybe 200, 100, or 200. Yes, 200, 100, 200, 100. Put your own values. I just want to see whether is it like executing. So now press enter and see. Go to the turtle window and see whether is there any. Okay. But you can see the roof has taken that. Okay. And can you see the point that I have mentioned? So that your function is okay for the given values. Can you understand that? Your function is okay for the
Yeah.
given values. But when it comes to the second figure, yes, it is drawing that the roof and the wall segment is proportionately arranged. But that we have discussed yesterday also, right? Roof and this wall is proportionately arranged. Okay, you can try something else also. So go to the shell again and type house, and then this time 400 and 300. Okay, okay, this is a large one, you can see. Okay, roof and walls, okay, but now see the window and the door, right? So it is not proportionately arranged. So that is the point. Like you have done it very good, but you have done the code. But this is how you think you should think in programming, right? So that is why people think this is difficult task. Otherwise, like just giving something or just giving instructions and getting things done is not that difficult, right? You can see that it is. So even though initially you might think like this is difficult, writing codes is difficult. No, it's not. It's really not. Do you think that is it difficult or is it easy? Writing codes? What do you think? Writing codes,
It's
is it easy or difficult?
sometimes it's easy and sometimes it's hard for me because
But actually, coding part is not difficult. The coding part is, so if you think, like if you rethink, so is it coding or building the logic? So what goes difficult? Is it coding or finding the logic?
probably finding the logic.
Yeah, finding the logic. That is the challenging point. So that is where the people fail. So people can code. Anyone can code. It's like English, right? So when you improve, you can talk. It's like a language. When you improve, you can talk. But talking with a sense and also becoming a public speaker is not easy. Why? Even though you have language skills, becoming a public speaker is not really easy. That is an art. That is an art. You have to catch them, you have to keep them listening to you, you have to keep their attention, the coherence, your experience need to be shared, and your message should be given in a nice way. It should be presented basically. So therefore, public speaking has something else. It has the language power plus some other soft skills. So similar to this, the coding is not difficult. Coding is just a language power. So if you want to learn coding, don't be so you don't even need to come to a class, or you don't even to listen to a teacher, because if you check in the internet to do something, these codes are there. Oh, there are now there are case tools, computer assisted software engineering or computer aided software engineering tools, which are capable of generating the codes. Now, for an example, even a mobile phone application, now you can create it without any coding. Those platforms are there. Dashboards or this drafts, charts, like the reporting environments or the report decision support systems, all these things, and HR systems, finance system, websites, you name it, everything is now there. So it's customizable, no need to code, no need to even code. But so then coding is not that much challenging, right? You have to understand that coding is not the challenging point. Only point that is challenging is the logic. So that is the difference. So one can become just a code writer. The other one can become a software engineer or creative code writer, or kind of a developer or engineer or software engineer, or maybe some higher position. But the gap is the understanding of your logic. So how you can think will develop your, so now what do you need to develop? The thinking pattern. But that is not really easy, because it is not naturally coming to us. What we have to do is we have to solve a lot of questions. After solving a lot of questions only, we get that knowledge. Okay, so let's see. So what do you think? So shall I give you 1 week of time to try this part, or discuss now?
I think I should.
Yeah, just give a try. It's a very small thing, right? Just analyze how this roof and wall, how we have proportionate. Just analyze the code. Just try hard, try little hard, and try to make. So we have here. So can you see the pad? So initially we have used a global variable called padding there. Padding is 5. So we started with the default value 5, but later we have changed that. So in your house one, can you see we have changed that. In the house, we have changed that to global padding. And so what we have done, we have analyzed the gap, and dynamically. Gap is the roof length minus window length. That will give the gap between the roof and the wall, roof part and the wall part. So once you know the gap, you have to divide by 2, and so proportionately share it to both sides. The padding, one side padding is actually half of the gap. So that is the logic. It's not difficult. One side padding is half of the gap. So similarly, roof starting point. So you can see roof starting point. Sorry, not door starting point. Door starting point is, it should be aligned with the bottom of this wall part. That means you know the height of the wall. Since you know the height of the wall, you can easily decide where to start the door. the window and the door. So when you know the door and when you know the wall, so you can proportionately place the door. According to the door, you can place the window. So just give a try. It's not hard. It's not that much hard, but you have to think, right? Okay. So let's move to the next part. Right now we learn about the functions, and I think you have clear idea about how functions are acting. Basically here you can see in this function, so some functions are running without parameters, or we can call arguments. These parameters are also called arguments, right? I'll write here. It's also called arguments, parameters or arguments. And so the function body is here. And sometimes the number of parameters you can decide, right? Number of parameters. You can decide number of parameters. It can be 1 parameter, 2 parameter, 3 parameter, any number. So better less number of parameters, because if more number of parameters, it is complicated to execute. But you can include, but when there are more parameters, it's very, very complicated to execute, because the executor or the person who use, maybe it can be the developer. In our case, we have used our own function. But in some cases, when we are importing libraries and all, we are using parameters given by some other provider, some other library. For an example, so let me show something. I want to divide 7 by 3. It says 2.3. But I can get 2 by 7 floor divided by 3, it will give 2. But if I want to get the seal-in value, I have to seal it. To seal, there is a function that is seal. So seal function can seal the value after dividing. But seal function is not defined, because it is not defined by the default libraries. You have to import. So that is why you need some extra coding that is written by somebody else. But here in Python, it is included. You can import math library to do that. After importing math, you can say math.seal. Then you can give the value to be sealed. Then you'll get the seal-in value. So here seal is the function, right? Seal is a function. It uses how many parameters? Yes, seal use how many parameters? Hello?
Sorry, my mic was muted. I didn't realize.
Sorry?
My mic was muted. I didn't realize.
Okay. So how many, how many parameters are there in seal function? Yeah, so what you observe this and tell me, right? In seal, seal is a function, right? You can recognize with the brackets, you can recognize seal is a function. So how many parameters are there?
7?
No. So parameter means just the values. How many?
Oh, okay. 2. Or no, 1.
No, it's 1, right? It's only 1. Because this is dividing, right? This is dividing. So that is only one.
Just one whole thing.
Yeah, only one parameter, right? That is the thing. So for an example, if I give math .seal, so if I give like 2.3, still it will seal. So, but that is only one parameter. But if you use 2 parameters, actually, but it will not be supported. You can see it has only X, only one parameter, right? When you're writing the tooltip text, or it shows the ideally automatically shows. I think the command space or control space to get this command space or control space. In Linux, I think control space should work. But you have to import the math, right? Okay, so another thing. So print is a function. Print is a function. So you can see here, when you go the command space or the control space. So can you see? So how many parameters are there in print function?
A lot. 1, 2, 3, 4, 5, 6. No, 5, 6.
Yeah, it has value. Then this triple dot means you can give any number of values there, right? Separated by commas. You can give a list, large list of values. So we can consider that as one. So separator. How we are going to separate these values, and the end. How we are going to end the value, and whether you are going to write it into a file or flushing means like you are going to flush the memory, etc. Anyway, there are multiple parameters. But print has flexibility. You can even use 0 parameters. That is print in empty line. Print has flexibility. You can print 1 parameters. It will print the parameter given. Print. So now actually we are deeply analyzing the things we have already done with the functions. And you can give the separator. So let's give the separator as a hash. Right? So we have not given, actually, we have not given, we have to give some values, right? Hello, hi, bye, something like this, let's say. And the separator is hash. So you can see hello, hash, hi, hash, bye. So that separator will be in between. Normally, if you are not giving the separator, so what will be the separator? When you are not mentioning the separator, separator will be?
Space.
Space, correct. When there are no separator, separator will be. So this is what you need to get. So I didn't explain this when we start the class, because we were not in a position to explain about functions. But now you know the internal structure of function and the parameters. Now what will happen? Actually, when you are learning Java, so in the next step we are learning Java. At that stage, right? At that stage when we are learning Java, so it is like this. In Java, we do something called object-oriented programming. In object-oriented programming, basically we have to do something so much better than this, And actually speaking, you will understand the first program after several steps, maybe after several days only, you will understand what was there in the first program. Till then, that will just be a code. You can just learn that as a code. That is only a code, but you cannot exactly tell what it was. You know, when you write this code, you can get this out. So that is why I didn't start Java initially. So when you write this code, you will get this output. That is the idea you will get initially, but later, gradually, when you are learning about these things, are functions, classes, objects, overloading, overriding, parameters, the polymorphism, and different concepts are there. So after learning all these things, then you understand, this was there. This is the class name. That is why this is encapsulated. Right, okay, this is, so likewise, this is a function. This is function with the parameter. This function has no parameters. This function is overloaded. So likewise, you will understand that, but it will take maybe, at least it will take 6 or 7 days to understand the first program. But with this background, that won't be a big problem, because like even the first day itself, you can get some idea at least. So that is why I'm prepared. Now, let's see what else, what are the other parameters. So now you can see hello, hi, bye. If I want to put a tab, I can give the separator as a tab. You know how to give a tab. It is escape sequence, /tab, /t, and we'll add a tab there. Hello, hi, bye. So you can add numbers, anything, right? So I'm just adding strings, but No need to be. Just say. Okay. So separator, and you know the end. Another parameter is ending parameter, and you can end with okay, separator, and end with, let's say, I want to end with 3 new lines. Can be done. After that, 3 empty lines. And what if I'm going to mention a separator is a new line? Separator is new line. So each of these will come into a new line downwards. So we have given one line, but it's coming in multiple lines. Anything can, so you can use the parameters, different way, and you can create these things. So just try these things. These are helpful in output formatting. These things will be helpful. Okay. So since we have clear idea on this about parameters, so let's see what else you can do with that. We have started drawing shapes, but we have to. These are some examples. Right. No parameter way of adding 2 numbers. So I'm not going to write. I'm not going to explain these. Write these codes again and again. I'm just explaining using the note. Let's do exercise to understand this after reading this. Okay, you can see no parameters, add nums will get x and y as the input, and total is x and y, and the output is formatted, and the total will be printed. So let's copy and run the function and see how it works. This is simple because we have done more complex functions than this. So let's take a new one and paste this, and this is my add nums function. Sorry, I think there's a problem. Right, can you hear me now? Minaga, am I audible? I think your microphone is muted.
Yeah, I can hear you.
Okay. Right, so let's see the add nums function now. X is getting the integer, y another integer, adding them together, displaying it after formatting. Let's run it. But when renaming, be careful. Don't give any names defined by add together. Use a different name, right? Otherwise. Okay. So when you run this, nothing there. Add nums. Call the function. Asking the enter number 1, okay, enter number 2, adding there. If I want to do this again, add nums, you can give any number. So you can see the function can be repeatedly called. That is the advantage of function. So we understood that yesterday also. It can be repeatedly called. Let's try this first.
This meeting is being recorded.
You can see here. Now let's move to the, so we have learned parameterize, no parameter, everything, right? So when you add the parameters, and you can add default parameters, so by giving assigning values, so that can also be done. So let's do another thing. Let's say something like this. I want to calculate area of a shape. Let's say area of a shape. Then I just need to give So this can be done for any symmetric shape, or circle for any symmetric other shape, right? So let's see. Yes, Minaida?
Oh, I'm sorry. My Wi-Fi stopped working for a second.
Oh, is it okay now?
Yeah.
Right.
Yeah.
Right. Let's say I want to calculate area. Right. I'm going to define a function. Area. First of all, I would like to ask a question. Type, or say T. Input. Telling enter the type. Enter the type. And I'm going to give a message first. Print. Circle. One. Square. Two. Inside a tab. Tab there. And triangle. That is 3. Rectangle. 4. So why I'm displaying? Because I need to limit this. Otherwise, if they are responding with different shapes, so my program will collapse. Therefore, so this is again a practice. When you are doing, when you are making a software, when you want to create a software, and especially when you are getting inputs, you need to filter it. So think about ATM machine. You know how ATM machine operates, right? So,
Yeah.
but it has limited options. Do we have any option there? So all the banking facilities in ATM? No, it has limited options. You can withdraw. So if it is CDM, you can deposit. So withdrawal is also having like limited options, like few options. You have to select from these options. So that is here also. When you go to the file menu, you are given a task. Select from these options. They are not asking open question. So when you open Word, it's not asking open question. Please tell me what you want to do. Then we type, I want to open a document. Here's your document. That is not normally happening. Right? That is not normally happening. It can be done with artificial intelligence, natural language recognition, artificial intelligence. It can be done. But normally, we have limited choices. Right? Understood?
Yeah.
Right? We have limited choices.
Mm-hmm.
We don't have all the options. So normally, but there are artificial intelligence applications like Siri, Cortana, right? Cortana-like thing, Siri-like thing. You have that artificial intelligence applications. So let's try Siri. Siri, can you open PowerPoint?
On it. Working on that.
Okay, you can see. So that is with AI. AI has this natural language recognition, all these things in place. But normally, under normal software, normal applications, we have options, selections, menus, buttons. Here in Word, you have buttons, menus, tabs, right? So these are the things which can be seen in a program. Similarly, we have to give the options, right? That is why I have given this. Okay, any questions?
No.
Okay. Then enter the type. Okay. Separate. Okay. If, then I'm comparing. If this T, let's take it in here. If this T equal to 1, area circle, and if T equal to 2, area circle, and if T equal to 3, right? Okay, let me run this now. When I run the area function, so it will first ask, enter the type. So if I enter 0, it says, please enter a valid option. 0 is not valid. So these are the supported options, because this is a command line application. This has no graphical user interface, no menus, no icons. We have to give everything in the text format. Okay, now your task is write in the other functions. So for an example, area circle. So let me write one for you. Def area circle. It needs 2 parameters. Area circles need 2 parameters, or you can just write without any parameter also, or you can just say the area circle, or just write that. That is meaningful, right? You can say R int input. You can say real int real, right? Float. Float is anyway supporting the decimals also. Float input. Enter the radius. I'm returning So what is the equation to calculate the area of circle?
Area of circle. 2 pi radius.
Pi radius. Is it circumference or?
No, that's area.
Right, circumference.
Oh, circumference. What is the circumference?
Yes.
I think. Oh wait, I think the circumference formula is 2 pi r.
Yes, circumference is 2 pi r. The area is pi r squared, right? Pi into radius, right? Right. You can say const E equal 22 divided by 7. And we can return pi r squared. Or you can just get the constant from, like, you can import it and you can import pi, right? That is also possible. Or you can just mention this pi equal this. This is an example using this also. This way also you can create, or you can just import constant from the constant library. That is also possible, right? I need to put const. You can just define as a variable, or you can just get it from the constant library. Example. So let me import the constant. Here you can say constant dot pi. Say p equal constant dot pi, return p into r into, sorry, p into r into pi r square. So that is, yeah, we're going to return that. So this returning thing, I need to introduce this today. Returning thing will not print anything. Okay, let me show that. When I run this file, constant module, why it fails? You can keep it in a different file, but so let's do like this. Let's, without using the constant, let's create. Sorry, something wrong. Okay, so let's use the value, right? P equal 22 divided by 7. That is easy.
This meeting is being recorded.
Let's run this. Then I'm calculating the area circle here. It will ask me the radius. Let's say radius is 7, and it is giving me the answer. So this is when you run the function directly. I'm not printing, I'm returning.
Oh, I can't see the screen. It's a black screen.
Is it? Wait.
Okay, now I can see it.
Sure.
Oh. Okay, I can see it now.
Right, okay. So this is the area circle function to get that. Actually returning, what returning is, returning can keep the value right? Keep this value for some time. It's like storing the value inside the function itself. You're not immediately printing. Later, when you need, you can print. For an example, you can do something like this area circle, and I'm assigning this to an answer variable. Let's say answer is initially 0, and here I'm telling answer is equal to area circle. So this is how I can capture. Since this has a returning value, I can capture the to answer variable. Later, I can print answer is in this answer variable. Okay, let's see the execution of this and understand this now. First, I'm saying area. This is the master function. It's asking which type. I need a circle. It's asking the radius. I'm giving 14. Your answer is 616. Actually, answer is calculated by this function, and the value is passed to the answer variable. That is then taken here and printed. So please understand carefully, right? So this is how functions deal with each other. When you call this area circle, the first arrow, this will be executed. Then the second thing is this answer will be recorded into the answer variable. The third thing is that answer will be printed as the final answer. So sometimes bit confusing. I'm numbering. This is the number 1. When you call, the function executes. When you execute the function, the answer will be given. When you get the answer will be printed. So you'll get the final statement. This is the execution cycle. Okay, try to add the other functions also. Please try to add the other functions too. Area circle, okay. Area square. Square is easy, no? Yes. That is
Meeting is being recorded.
Triangle is getting the float value of this. Length of the sides. Half. Okay, correct. Take the square and divide by 2. The dividing you can do it in the, so that doesn't matter. Dividing can be done in the like t into t base. You can just divide it by 2. Right? But it's okay. So anyway, please.
Oh, okay.
Okay, then yes, that is it. Good. Right. So this is how a returning function returns values, and this returning function after return. So it can be captured by these and then printed. So rather than printing individually in these functions. Okay. That's it. Let's quickly refine this to finish it, and area square. Rectangle. Square. Width at the breadth. Say enter width and the breadth or length. W and L. Oh, length is enough, right? Length is enough. Return length into length. Triangle. Right, okay, let's do another thing. Right, so this is the note related to this. You can just take a screenshot, and I'll be anyway sending this part to you, the returning and non-returning function, the difference. So that is what I have explained. The returning function, the non-returning function will simply give the output, but returning function will allow you to keep the output within the function and later assign that to a variable and use it. So that is the returning function. So yeah, with the time constraint, the recursive function thing, that needs some time. Okay, doesn't matter, right? So let me explain the recursive function also. Recursive function is where function call that function itself. So something like this. Let's say there is a function print numbers. Print numbers. Print now. Let's say you are giving the starting position, or you are just giving nothing. So let's say this function print let's say that's a number like x equal 0. It's printing this x, and I'm again writing the same function. That function call I'm writing inside the function. So this is a bit odd, right? So writing the function call inside the function, and then I'm giving x plus 1. So what will happen if I run this function? So can you guess what will happen if I run this function? Think and tell me. Hello, I think you are muted.
Oh, okay.
This is the function. If I print the num, what will happen? You can see x is initially 0. 0 will be printed here. Then so I'm putting an x here, right? Same x here. X is 0, 0 will be printed, and then x plus 1. X plus 1 will be the next x. What is x plus 1? Hello?
1.
X is initially 0. Right? Then I'm
So it'll be 1.
x plus 1. Yes? 1. Yes, 1. Then the next.
Yeah, it'll be 1.
X will be?
2.
The next will be? 3, right? So when it's going to end? It's not going to end. So it's going to keep printing these numbers. Can you see?
Yeah.
It keep moving, right? Never end. So this is called recursive. Recursiveness. Recursiveness means keep calling the same function again. So no loops. I'm not using any loop. Instead of that, I'm just calling the same function within that. But if you want to limit, you can do something like this. Since this is a loop, you can't break. Since this is not a loop, you can't break, or you can't continue break. These statements are not applicable since this is not a loop. But you can do something like this. If you can make a condition, if x less than or equal to 10, then only do this. Otherwise, don't do anything. Okay, let's run this now. So now I'm telling print num1. Going up to 10 and stop. So this is similar to the for loop, while loop things that we have learned, but it is not using any loop. Instead of that, it is using the same function. So since you have 1 week of time, I would like to give 2 exercises. Number 1, try to complete that house exercise. Number 2, can you remember the activities we did with loops? Printing patterns, printing stars.
Yes.
Can you try to do the same using this recursive function? But this is simple, but I need to explain more. First of all, I would like if you can experiment on this. Just give a try. So these odd numbers, even numbers, square numbers. Just give a try. Okay.
Okay.
Right. Then I'll stop from here. Good night. Bye.
All right. Bye.